Hello, my name is Melissa, and I will be going over valence bond theory. I will be producing a VSEPR diagram, a box diagram, and a contour diagram of nitrogen trichloride. First thing we'll do is determine the number of electrons in each atom. For nitrogen, there are 5 electrons. For chlorine, there's 7, but we have 3 in the entire molecule, so that makes it a total of 21 for chlorine. Total number of electrons is 26. Now we could divide that by 2 to determine how many pairs we will have, or we could subtract them as we go. I will start off by drawing the Lewis structure so that you could visually see your bonding pairs as well as your lone pair, and that'll help you determine your arrangement. Nitrogen will be your central atom, and attached to it will be your chlorine with bonded pairs. Now I will be assigning our pairs. Right now we have 1, 2, 3, so 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13 is going to be our lone pair. So as you can see, we have 3 bonding pairs, which are right here. 1, 2, 3, and 1 lone pair, which is there. So if we're looking at our list of total electrons around an atom, there would be 4 electrons around the atom, making that a tetrahedral. And then because there's 3 bonding pair and 1 lone pair, this would make it a trigonal planar for our molecular geometry. For a VSEPR diagram, everything remains the same. This time we are trying to simulate what it would look like to have a 3D molecule of nitrogen trichloride. So nitrogen will remain in the center, but this time we're going to draw a wedge, and that wedge is supposed to represent a chlorine atom that is protruding towards us, and then you will have a line that shows that chlorine is on the same planar as nitrogen, and then dashes will represent the chlorine atom behind the nitrogen. And then we will have our lone pair. And now if you look at the orbital bonds, you'll see that there's 4. There's 1, 2, 3, 4. So this indicates that it's going to be an sp3 hybrid bond. As for the angle, it's actually going to be 100 or less than 109.5. Sorry about that. That's specifically to ammonium. So 109.5 degrees for your angle. And so this will be the lone pair to bonding pair. Repulsion is greater than bonding pair to bonding pair repulsion. Now we will be moving on to the hybridization for N. We have the ground state, the excited state, and then the bonded state. And now for our N orbitals, we have 2s, 2p, and for nitrogen there are 5 valence electrons, so let's draw that in. That's going to be 1, 2, 3, 4, 5. This pair here will serve as the lone pair, and then these 3 will bond to chlorine, so we don't have to excite anything, we could just move straight into hybridization. Okay, so here's our lone pair. And then our chlorine is going to bond to that. Chlorine is 3p. It has 5 valence electron as well. And our lone pair here is going to bind with these 3. And then forming sigma bonds. And now we have our bonded state. Now we could move on to our contour diagram. Our contour diagram, I'm going to draw it the same way that we drew our Vesper, but this time we won't have any wedges, lines, or dashes. This time we will be bonding it to our orbitals. So nitrogen remains in the center. And then our first orbital is going to be sp3. We should have 3. And then we're going to indicate our lone pair, which is here. And we'll give everybody the electrons. The next orbital to bond is our 3p. So that'll be shaped like an 8. And these will be labeled 3p. And these are our chlorine. So this represents our trigonal planar. Our hybridization, which is sp3. And then we will label our angle, which is going to be less than 109.5 degrees. And this is because our lone pair to bonding pair repulsion is greater than our bonding pair to bonding pair repulsion. And that's it. Thank you for watching my valence bond theory on nitrogen trichloride.